Hey everyone, so in the last video we looked at rotations around an origin. Now we're going to look at rotations around a point. So when I mean a point that is not the origin. So you can see I've labelled a point here, 0, 1. It could be any point. I've chosen a nicer point so that you can get the idea. And in a moment, once we've done one example, we might change that point to see how it changes. Alright, so I'm going to choose maybe a value like over here, let's say. Alrighty, so to rotate this pink value against the blue value, we need to think of the blue value as the origin. So what you could do is you could draw a new axis and find the coordinate here. But I personally prefer just to go like, what is the difference between these two values? Alright, well the difference here is -2. And then what's the difference in the height? Well, it's 1. Alright, so I'm across 2, up 1. So even though this is not the coordinate of this point, in this actual coordinate would be -2, 2, I'm accounting for it in regard to this being my origin. Alrighty. So we'll write our order just like normal, 2, 1. And then we think about where we want to rotate. So let's say we want to rotate it to the third quadrant, down here. 90 degrees anti-clockwise. Well, then I need to switch them because they're neighboring quadrants. 1, 2. And then in the third quadrant, x is negative, y is negative. -1, -2. Now, that does not mean plot it -1, -2. It does not mean down here. That's -1, -2. Do not plot it there. What it does mean is -1, -2 in regards to this being your origin. So we're going to go -1, -2. And you'll see that that's 1 unit higher. And that would make sense because we started from 0, 1. So if it was 0, 2, then we'd be -1, 0. If we started at 0, 3, it would be -1, 1, and so on. So then, once we've done that, we can rub out our coordinates and we write the actual coordinate. So in this case, the actual coordinate here would be -2, 2, as we said before. And the actual coordinate here is -1, -1. And if we draw a straight line between these, you will see that we get 90 degrees. Alright, a right angle triangle. If we just look at that, boom, easy peasy. So let's say that 0, 1 changed. Alright, so let's remove all of this because if our origin changes, our entire rotation will change. So let's say our origin is now maybe over here. And I want to rotate this value. Alright. So once again, I don't care what this value is. I only care about what this value is in respect to this value. So I'm going to go 1, 2 to the left. And then I'm going to go 1, 2, 3, 4, 5 up. So that's my coordinate in respect to the blue value, the center. And let's say I want a 90 degree clockwise, because in this case, counterclockwise is going to go off the page, somewhere over here. But clockwise will be somewhere over here, somewhere. Well, all we need to do, once again, is we write our order out. 2, 5. Because it's a neighboring cell, we switch it. 5, 2. And in the first quadrant, both are positive, so we're going 5, 2. 5, 2 from our blue point. So I'm going 1, 2, 3, 4, 5, 1, 2. Alright, so this is our rotational point, our rotation. So now once we've found our rotation, we can start writing the actual coordinate. So this coordinate, the salmon color would be -1, -2, -3, and 3. This blue coordinate would be -1, -2. And this other salmon color would be, was that 1, 2, 3, 4, 0. Voila. And once again, if I draw a black straight line, doesn't have to be black, but it's nice and easy to see if it's black, you'll see that we do get a right angle triangle as we preferred. Alright, and that's all it is. So have a shot, try a couple questions, and hope you go well.